All right, here we go. So we're on section 9.5. Alternating series test. Okay. So remember that 9.6 is the last section that we cover before we take a test on the first unit of chapter 9, which is all of the tests for convergence and divergence. And the plan is to take that the Tuesday that we come back, okay, from spring break. So we will finish alternating series today. We will do 9.6 tomorrow, which is the ratio test. And we'll come back from break and we'll review everything again and then test on Tuesday. Okay? And then head into the end of chapter 9. Yes?
Are there any special tomorrow besides learning 9.6?
No.
I'm not gonna be here.
Okay, make sure you get the information, the paper before you go.
Also, I'm not gonna be here the Monday we get back, so can I get this?
Yes. If you're not going to be here tomorrow or the Monday that we come back, make sure you see me before you leave today. Okay. So, an alternating series is a series whose terms
And then my other trip
are alternating what?
It's like two different
to New York with my school.
three different terms.
If they're alternating
Switch between two terms.
between what? Positive and negative. There we go. Or alternating positive and negative. Okay, so here's a couple of examples.
Isn't it like the very first section? Oh, you're telling us about how like this one that creates a zigzag, it doesn't converge or diverge, just kind of wherever.
No.
Never mind then.
Okay. All right, that alternates, right?
Yes.
Okay, positive, negative, positive, negative. So help me write the series that describes what's happening.
So the sequence is alternating between the positive and negative. Not necessarily the sum.
Yes,
Okay.
So
yes. Whose terms are alternating? Yes, so that would
So
indicate
if you
sequence.
sum from n equals 1 to infinity of negative 1 over n.
Or negative and
Or
square
what? Or
negative.
well, negative 1 times.
It's fine. I'm just going to write it like that so I can see the 1 over n. I want to see the alternating part out by itself.
Okay, I was like,
But what power does it need to be raised to?
To the n minus 1 and plus 1.
N minus 1 or n plus 1, right? But we're going to make it be to the n plus 1 since we're going up. Okay? Since we're increasing our terms.
So what does it look like? I can't understand. What's the equation?
Oh, it's the series from n equals 1 to infinity of negative 1 raised to the n plus 1 power
And is it multiplied
Times-
by 1 over n?
times 1 over n.
Okay.
Yes, times 1 over n. Right, because the n right here is just these terms, right? And then the negative 1, if I plug in 1 right there, this power is even, so this becomes
Positive.
positive. If I plug in 2, that power's odd, so it's negative, right? Okay? So here's another one, negative 1 minus 1 over 2, plus. Negative 1 plus 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial. So,
Negative 1 and plus 1. plus n factorial, 1 over n factorial, times 1.
Okay, help me out here.
Yeah.
To the
And
n, right? It needs to be to the n, not the n plus 1 or n minus 1, because the first term was negative. Okay, so once again, what I'm interested in is whether this thing converges or diverges, right? All right, so we'll write down the definition and then we'll go from there. So let's look at the alternating series test. If a sub n is greater than 0, then all alternating series of the form the sum from n equals 1 to infinity, negative 1 to the n a sub n, or the series from 1 equals n to infinity, negative 1 to the n plus 1 of a sub n. Let me give you a minute to get that down. If a sub n is greater than 0, and notice that my a sub n is the term generator without the negative 1 piece, without the part that makes it alternate. Okay? So if that's greater than 0, then all alternating series of this form converge if the following conditions are met. The first one is this: the limit as n approaches infinity of a sub n. What do you think that's going to have to equal if this thing has a chance at converging?
0.
0. The terms of that sequence have got to be approaching 0 if we're going to have a chance for this thing to converge. And then the second thing is the set of numbers a sub n, or the sequence really is what we're talking about there, is decreasing. So a sub n plus 1 has to be less than a sub n.
So it only converge with at least those two criteria.
Yes, for all n. And then I'm going to put in parentheses, if you were ever asked to like really prove that it's decreasing, what would you need to show?
Take the derivative.
Yes, that the derivative of a sub n is less than 0. Okay, there's one other really important piece of information here. The alternating series test can only be used to show convergence. In other words, it doesn't allow us to test for divergence at all. It's like these things are met and it converges. If they weren't met, then we don't, well, I'm going to show you what happens. Okay? If the limit as n approaches infinity of a sub n does not equal 0, then the series will do what? If that sequence of terms is not going toward 0, then this thing would have to do what? Not converge, which is the same as diverging. Okay. then the series diverges by the nth term test. It's not diverging by the alternating series test, it's diverging by the nth term test. So remember, the nth term test can only be used to show divergence. Alternating series test can only be used to show convergence. So, yes.
So if we use the alternating series test and it shows that it's not converging to prove that, we have to use the interim test to figure out divergence?
Well, I mean, basically, here's what happens. When you do the alternating series test, the very first thing that you perform is the nth term test, right? It's the first requirement of it. And it's that's just like all the other ones we've done. We usually start with the nth term test. And if the nth term test goes to 0, then I've got to do some more work, right? Well, in this particular case, when it goes to 0 and I see that it was alternating to begin with, my next step is just to make sure that those things are decreasing, and then I'm good to go. Okay, so it all goes back to that nth term test being first. So let me kind of show you, I'm going to give you a visual here for the alternating series and convergence, okay? And we're going to start with, I want you to think about this one, this very first one that we wrote down, okay? So for term 1, here I am, I'm at 1, right? Okay, that wall right there is 0. Okay, I'm at 1. What was the next thing that we did?
Subtracted 1.
We subtracted a half. So here I am, right?
And you added a third.
And then I added
1.
a third,
Subtract this.
and then I subtract a fourth, and then I would add a
Fifth.
fifth, subtract a sixth, right? And so what happens? That interval approaches,
Something number.
well, the
Zero.
distance that I'm traveling back and forth is approaching 0, right? So that's why that thing would have to converge if those two criteria are met. Because if the terms are decreasing, then that's what's going to happen. You're going to take that first step backward, you're going to go a little bit forward, a little bit backward, a little bit forward, a little bit backward, until you're, you just have, you have this number. Now, as it approaches infinity, that distance is approaching what? 0. So it becomes insignificant when you talk about a partial sum. If you're going to do a partial sum, then that distance that you're going back and forth becomes so small, it's negligible. Josh?
Are we gonna be able to find out that point, where it converges to? Or is that-
You know, we are going to be able to find a range of values that it falls between, okay? While we're on it, okay, while we're talking about it, let's talk about the error associated with a partial sum approximation of an alternating series. Okay, so here I was at 1 again, right? Here I am at 1. Let's say I want to use the 5th partial sum to approximate the sum of the series, right? And in reality, what we would do is we would plug 1 in, we'd plug 2 in, 3 in, 4 in, 5 in, and we'd add all those numbers together, right? Okay, so here I am at 1. I'm going to subtract a half. So now I'm at 0.5. I'm going to add a third. So now I'm at 0.8. I'm going to subtract fourth.
0.55.
Yep, 0.65, right? Yep. And then I'm going to add
No, it's 0.55.
Maybe 5.
a, okay, all right. Okay, and I'm going to add a fifth. Okay, and now I'm at my partial sum, and it's something like 0.78, something like that. We did last month. Okay, so here I am. What is the maximum error that could exist at this partial sum approximation? I don't even need an integral. I don't need an integral. I'm not doing integrals here.
Oh, the 7th term?
The very next term, right? It would be the 6th. I stopped at 5, right? I did the 5th partial sum. So the next term
Yeah, it's 0.78.
is the biggest error I could have, right? Because after that, it gets smaller,
Smaller.
smaller, and smaller. So what happens is I can get this 5th partial sum, And I can find the remainder the error associated with it, which is just the next term. And it would be the absolute value of the next term, right, depending on how I'm going. So I can take that and add it or subtract it from my partial sum, and now I have this range of values where my sum is. So it's pretty, it's pretty intuitive, if you think about it. So let's summarize all of that in some words,
Okay, well,
instead of me dancing around up here.
so even if it's like going back and forth and it's going to this point, that's non-zero, right?
Yeah, because remember, things don't have to converge to zero.
They just,
They just, the sequence,
what,
no, that doesn't have to either. It just has to approximate a finite sum in order for it to converge,
okay.
right? It can't continue to grow without bound.
So like would the sequence converge for that to zero?
The sequence will approach zero. Remember, that's my first requirement, is that the sequence itself approaches zero. Because remember, you're gonna add those numbers.
So like if you do the sum and it converges, it's saying like it's all of these terms are being added up and it's gonna like end up being like.
Yes, your partial sum will be some finite value. Like, remember the telescoping that we put up yesterday? And we wrote out some terms and everything canceled out except the first term, which was 1/2, and the last term, which was something so insignificant that it didn't really matter. So we could say that series converged to 1/2. Remember, when you talk about a series converging to a number, that is the number that you're approaching if you added an infinite number of terms together. Okay? All right, well, let's get some more of this in writing. Actually, let's do a couple of examples first with just determining convergence and divergence. Okay, so let's determine the convergence and divergence of -1 to the n plus 1 times n over 2n minus 1. Okay, so the first thing I need to do is what? Say again?
Set a limit.
Do a limit, right? Do the nth term test, basically. Do the limit as n goes to infinity of the term generator minus forget about the -1 piece of it, right? I can ignore the piece of it that's making it alternate. I just want to look at the other part. Yes?
Would that always be obvious?
Good question. A lot of the time, yes, it's like this. I'm going to show you an example where it gets disguised, and they can disguise it within a trig function. But for the most part, alternating series, they're pretty obvious. They have a -1 to a power. Okay? All right, so what is this limit approach? 1/2. So what can I now say? Diverges by the nth term test.
I'm assuming if we write down diverges by the alternating series that you break down wrong.
Yeah. Sum from n equals 1 to infinity of -1 to the n times n over ln 2n. I have your quizzes graded, by the way. I just haven't entered them.
Can we go look over them again?
Yeah, if we have time. If nothing else, you can get your grade before you go. Okay, so limit as n goes to infinity of n over ln 2n. What does that approach?
Zero.
Infinity over infinity. if it doesn't pop off the page at you, and then you can do L'Hopital's rule. Or you can also say that this thing approaches, if you know the growth rates, which one of these grows slower?
Bottom.
ln grows much slower than that, right?
I assume what the 2 had to do with it.
Nothing really. So this would go, this whole thing is gonna go toward infinity, which means that it will diverge, right? It will diverge. If you can't, if you're unsure on the growth rates, you can go ahead and use L'Hopital's rule, which would be 1 over 2n times 2, which just becomes n, which is infinity. And since that doesn't go to 0, we can say diverges by the nth term test.
So can we, like, say we figure that out and we just set it equal, or we
From right here, you could put
equal.
infinity, yeah. But some people they're not as confident in the growth rates, so. Okay, so here's one of those ones that they can disguise.
It's cosine to the n pi over n.
Cosine of n pi over n. If n is 1, what's this thing equal? Negative 1 over 1. If n is 2, what's this thing equal? Positive 1 over 2. If n is 3, it is negative 1 over 3. Are you following me where these numbers are coming from? Because at every odd value of pi, cosine is negative, and every even value of pi, it is positive, right? So this can really be rewritten as the sum from n equals 1 to infinity of what? Negative 1 to the n times 1 over n.
Which feels like n times pi halves. Where it goes like 1, then 0, then negative 1.
That would be a different problem. Because these have to alternate exclusively between a positive number and a negative number. Okay, so what am I going to do first? Limit as n approaches infinity, right?
As you approach 0.
Yep, so it approaches 0. So I got one thing checked off my list, right? What's the second thing I have to show?
So it's decreasing.
That 1 over n is decreasing, right? If you think about that, it's pretty obvious that it's decreasing, right? 1/4 to 1/5 to 1/6 to 1/7. But I can show it.
I would just like write decreasing chapters like that.
Well, I mean, technically you should, if you were doing a free response question on the AP, they would want you to show this. They would want you to show that it was always negative. If you aren't going to do this, at least write me a few terms. You could say something like 1/9, less than 1/8, less than, you know what I mean?
Wait, are we done with that?
Yeah, yep, oh, sorry, no, I didn't actually draw the conclusion. What do we get to say now?
Therefore,
Converges by alternating series test. Thanks, Haley, sorry about that. Okay, so again, I'm going through a bunch of problems on series, whether they converge or diverge, and I get to a problem that looks like that, and my brain should automatically go to what? Try the alternating series test, right? That is an alternating series. And then I know that the first thing that I need to do for an alternating series is limit as n approaches infinity of 1 over the square root of n. Which does what? Goes to 0, right? Please do not confuse this part of the problem with doing another series. Like last block, I wrote this down and somebody goes, that's a divergent P series. I'm like, yes, if we were doing that, but that isn't what we're doing. Okay, we're in the alternating series test right now. So I've shown that it equals 0. What's the next thing I need to show? That it's decreasing, okay? So, the derivative of n to the negative 1/2 is negative 1/2 n to the negative 3/2, right? That's less than 0, therefore decreasing. Therefore, what do I get to say? Converges by alternating series test, right? One more. Okay, so what do we? You might want to rewrite it. Yeah, right? So it's like negative 1 times 1 over 3 to the n. You don't have to rewrite it that way, but for some people it's just easier to see it. Okay, so clearly this is an alternating series, so the first thing I'm going is limit as n approaches infinity of to the n. Yeah, since 1/3 is smaller than 1, I know 0. So there's part 1. And then I've got to check that it is decreasing, right? So this one's kind of a pain to take the derivative of because the variable's in the exponent, but I'll just give you a refresher on that because it is something you need to know. So it's like you would let y equal 1/3 to the n, and then I would ln both sides, and then I would take the derivative. I need to take the derivative of the n term, right? So this would be 1 over y dn dy dn, sorry, dy dn. This is a constant times a function, so the derivative is just the constant, right? And then I would multiply by y. So the derivative here is ln 1/3, and y was equal to 1/3 to the n power, right? ln to the 1/3 is always positive, is it not? But ln to the 1/3 is what kind of number? It's a constant, but what kind is it? Negative. This is negative, right? Because doesn't this mean e to some power equals 1/3? Well, e is 2.718, right? So the only way you could make e change from 2.718 to 1/3 is by raising it to a negative value. That's the only way you could make it smaller. So this is always negative, so this is always less than 0, therefore we're decreasing.
What's your
Therefore-
exponent there?
Say again?
What's your exponent in the ln of 1/3, 1/3?
The n.
It's an n.
This?
Yeah.
Yes, that's an n, sorry.
Why are there two 1/3s? I'm not following.
Okay, we let y equal 1/3 to the n from the very beginning.
Oh, okay.
Okay, so we had to let y be that in order to even start the problem.
Okay.
Okay, so then when I did the ln, right, I had to take the natural log of both sides so that I could bring the exponent down in front. So that's how I got the ln of 1/3.
Okay, and
And then when I took the derivative of ln y, that was 1 over y. And when I moved it to the other side, I ended up multiplying by, instead of putting the y there, I put what y was really equal to.
okay.
Okay, so therefore this series what? Converges by
Yes.
alternating series test.